Thank you. Right. So I'm Markus. I'm working as a build and release engineer at Luminar, and we are currently in the process of migrating to Bazel. And our approach that I want to share with you is we try to do that with fully ephemeral build files. So this means we don't want to track our build files in version control at all, but we want to automatically generate them. Now, before we look at the Bazel part, let me give you a quick introduction of what Luminar is. So our core product is mainly a LiDAR. So we're a LiDAR company and we're building up this LiDAR from the chip level. And our LiDAR is a long-range LiDAR, so you get up to 200 meters of range where you still get the resolution required for autonomous driving. And on top of this LiDAR, we have an entire software stack, including things like perception, mapping, and also some driving functions. And this is the software stack we're talking about that we want to migrate to Bazel. Now, some background about where we currently are, what our requirements are. So we have a mono repository for this software stack, which is mainly C++. There's also some Python around as tooling and some other languages, but they're minor compared to core C++ code base. And we're using GitLab CI, which we run about 20,000 jobs a day. So this includes building, testing, building Docker image, all that stuff. And our requirements are we want to build our software for different architectures, of course, for different platforms with different compilers. This also includes compiling some CUDA code to bring our perception models on the hardware. So this is a quite wide range of architectures, platforms, compilers to support, depending on our customer. And at the very end, out of our single code base, we want to create different binaries, libraries, SDK, container images, depending on what the customer needs. And yeah, this builds or has some requirements on our build system, and we're currently on a component-based build system. So this was before my time, but Luminar started with a monolithic CMake code base, and then over time and scale, of course, the build became slower, and then people did a kind of small step towards Conan. So for those of you that don't know Conan is a C++ package manager, which more or less can be used to instrument CMake or other build systems, but primarily CMake, to do then the actual build. And this allowed us to split this single monolithic CMake project into multiple smaller ones. And then the individual Conan packages could depend on each other. You get then remote caching, and you just have smaller packages. But it turned out, again, over time, that we're kind of abusing Conan as a build system because it's primarily designed as a package manager, which means you have one repository with one Conan recipe, which is uses SEM version to create its version, and then other packages can depend on it. But in our case, we ended up with having hundreds of Conan packages within our mono repository. And of course, you don't want to have semantic versioning, but you want to have this based on the changes. So this forced us to have a kind of handcrafted build system on top of it, which means creating our own dependency graph, detecting changes, just wrap something around Conan that makes it work for a mono repository. The good thing is this gave us, again, remote caching and made our builds, again, faster, but it requires some manual effort, maintenance effort, and we want to get rid of this. Then some other requirements we have, which is very nice with Conan. There's the Conan Center available. Lots of third-party dependencies are available there. So you just grab them. We can vendor them in our own infrastructure. So this is nice. But this is something we also can and want to do with Bazel. And on top of that, since we're in the automotive context, we have some requirements. So we have to run some static, dynamic code analysis. We have to do code coverage. In the driving context, the requirement is even to be at 100%. So we have this also gating in our CI. Yeah, Flanked ID, AutoZer, all the thing that comes if you want to go to the car. And this is quite nice to do with Conan, because Conan is Python based, so you can just hook in all your tools. And that's now something we also require in Bazel. So our goal was clear. We want to migrate from our current handcrafted build system around Conan towards Bazel. And since we already have this kind of well-structured Conan packages, we thought, hey, we can create a tool that automatically converts these Conan packages into Bazel package, or basically writes the build file for this certain folder. And we started doing that. And after a very short time, we realized, okay, the code base is moving that fast that every time, or sometimes people introduce changes that cause our tool, or causes issues for our tool. So we had to first fix that before we could move on, adding more features to our tool. So ideally, we want to have our success covered by CI. So, but we also don't want to have our developers to main 2 build systems at a time. And we also don't want to write any glue code that makes part of the code base working with Bazel while the other part works with Conan. So we thought about, okay, we already can generate our build files based on our Conan packages. Why not going the full path to the end and always try to auto-generate the build files? And that's then the approach we decided to go for. And yeah, that's how we do it. So we found Bazel. Bazel is part of the code project of the Go project, which is used to generate build files. So it understands the syntax of build files, so you don't have to mess around with the syntax itself. You just can write a language extension, which we did for C++. And thanks to our Conan packages, which have a quite well-defined folder structure, we just look at the folder structure and are able to identify these parts belong together. And then we also defined one header file, or in case there is a CPP file, should go into one target. This means we have really small targets, but which is good for Bazel because it can parallelize as much as possible, and we can really leverage the remote cache. And we did the same for the tests. And yeah, with this, we have one target, and we figure out the dependencies by then looking at the include statements. So whenever you include a header, we know for this header, there must exist a target which has the same name. So that's how we can generate the dependencies. Of course, this will end up in quite many dependencies, but since we're auto-generated, nobody cares. And yeah, we also added some more support for data dependencies that come in if you need some tests and you need some configuration files, binary, whatever as a dependency. We also parse that from the source code and auto-generate it. But still, this means you probably can generate 99%, but there are always some developers that have some edge case situations. And for this, we came up with the approach of manual targets. So we designed, or we use a build.bazel.in file, which allows the developer to specify manual targets. So whatever you write there will always overwrite what Bazel does. But still, we don't want developers to specify then all the dependencies for the manual targets. So whenever you leave something out in the manual targets, Bazel will know, okay, I have to generate this. That's our approach for the build file generation. And on top of that, we use NixOS for getting our third-party dependencies or the Bazel toolchains. So of course, we try to use Bazel for getting third-party dependencies, but some of them are trickier, such as Boost. And yeah, for those, we're not able to make them work with Bazel right now due to the team size and the workload. So for this, we use NixOS. All right. And yeah, this brought us to the approach that we can auto-generate most of our build files, and the developer workflow is then just Bazel run Bazel. It takes a few seconds, so it removes all the build files locally or in CI. They are not available. It generates a fresh set of build files, and then the developer can use Bazel as they are used to. And now for us, it turned out that's a quite nice approach, because we have now 2 build systems running in parallel, but Bazel comes with almost 0 overhead of maintenance. And with this, we can continuously increase the coverage of things that already work with Bazel. We have them gating, and developers can already use Bazel for their local development for parts that already work, and the rest is still covered from our old build system. So everything that goes into products, gets released, everything that is not working with Bazel yet is still covered by the old build system. And also this means less workload for the Bazel migration team, because we don't have to support developers in working with the build files, but we can focus on getting new features new features in that we can move on with the migration. And once we have full coverage of Bazel, we can also slowly fade out Conan and completely avoid a big bang migration. And so far, we got very positive feedback from our developers, especially the ones that already experienced big Bazel migrations in their former companies. They reported to us they're quite happy and surprised how minimal the maintenance effort for the Bazel migration team is, and also how small our team is. So it's mainly myself, a few other people that do it on the site, and also Finball, who's sitting here in the audience, who supported me. But that's it. And we're able to do this migration with very few people on the actual migration team and roll this out to the developers. So thank you.
Thanks a lot. And we even have a few minutes for questions if there are any. All right, I'll start in the front here.
Which tools do you use for coverage management?
Yeah, so since we're in C++, we use gcover, gcov, llvmcov, depending on the compiler. So we have what we call a quality tool chain. So that's what includes all the check, Klangtidy, and also coverage. Right now we're still at gcover, but we want to go through to llvmcov. That's something, one of the features I mentioned, we're still working on.
All right, there was one other question.
So we had a similar thing where we were migrating our Rust packages to Bazel, and we decided to use repo rules to do it. And so that's how we would normally generate our ephemeral build.bazel files. Did you consider that? Was there a reason why you chose this instead? We just use repo rules. Yeah.
I can't remember exactly. Could be that we had this in our plan, but we just compared different solutions, and Bazel seemed like a kind of well-designed, well-used tool for that. So that's why we decided for Bazel, and so far it works quite nice. Maybe one addition, since you mentioned Rust, we also auto-generate kind of our, we're using rules Rust, and if we see Rust messages, then we also generate targets that make the Rust headers available. So that's also part of our Bazel workflow.
Yeah, let me do a shameless plug since Bazel has come up. So Jay Conrad on our team is an engineer who created Bazel. So if you have more discussions on the subject, please talk to him, especially the C++ extensions and other things, because we're interested in doing more work there.
All right, thanks a lot. That put us right at time. So let's move to the next talk. Thanks, Markus, again.